This video is going to be about the fuel pressure sensor from this Mercedes W177. Here is the sensor on top of the fuel rail with a 3-wire connector. And here I have a screenshot. And on this car you're going to find this interesting data PID engine fuel rate. The usage of fuel has to be direct proportional with the calculated load value, not necessary with the engine RPM, because the engine speed can increase, but if the engine is not working, is not under a load, it's not going to consume that much fuel. So you can see that right here, the engine RPM was up, but the fuel rate was stable until the point where the calculated load value increased. So the stress on the engine increased, and then also the fuel rate increased. So this data is telling us two things. First, it looks like the high pressure fuel pump is able to deliver enough fuel pressure, since there are also no errors reported to the computer about the pump or the sensor. And second, we know that the injectors are also responding and delivering fuel when necessary. And actually we also know that the first fuel pump inside the tank, which delivers the 5 bar of pressure, it's also working. Let's increase the engine RPM and you can see it's using more fuel. Now I'm going to connect the voltmeter to a ground. Under here is the main ground. I've got here a charger, since I'm gonna turn on the ignition right now. First pin, we've got 5 volts. The middle one, 0.01. I don't think that's a signal. And the right one, we've got 1.8 volts. So this is gonna be the signal wire, the wire from the right. And this is gonna be the reference wire, this one from the left. I think the middle one is the ground, so let's connect it here. I'm gonna take the other terminal of the voltmeter and connect it to the plus. We should be able to read 12 volts. And here we go. We can see 12 volts. The middle wire is gonna be the ground. I'm gonna switch this back to the negative. So the fuel is actually very hot. But anyway, we've got here back a safety clip. Let's just put it up. Let's unplug it. Now let's see what voltage we're gonna find with the connector unplugged. So again, in the same order, let's see the first pin here from the left. We've got 5 volts because this is gonna be the reference. This is gonna be the ground again. And this is the signal wire. Right now the sensor is not connected, so probably if you hook up a scan tool and read the live data, you're probably gonna see some very high pressure or very low pressure, depending on how the computer is programmed to interpret this 5 volt signal. So these are the values we need to read until now. Finally, let's see what resistance we need to read on this sensor. I'm gonna turn the voltmeter to ohms readings. But this engine is hot, man. I gotta wait a little bit. 45 degrees, but still, this thing is hot, is no joke. When you read ohms, it doesn't matter which terminal you connect where. It matters the 2 pins you are connecting. So 7.13 kilo ohms between the right and the middle. Now let's see between the right and left. Okay, we've got, is this 5.3 kilo ohms or 5,300 kilo ohms? Let's see between the middle and the one on the left here. 1,893 ohms. And here is the part number if you need it. If you want to replace the sensor, you can use a 24mm range or a 24mm long deep socket. Okay guys, so that was pretty much it about this sensor. If this information was helpful, give this video a thumbs up. If not, let me know in the comments what would you like to see. Take care and have a nice day.